Welcome to Snack's Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about forecasting. This topic is based on a tech blog with the title Running Demand Forecasting Machine Learning Models at Scale, written by the data science team from Picnic Technology. You can find the link to the blog in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Picnic Technology is a company headquartered in the Netherlands, and it operates a digital supermarket across Europe. The company has developed an app-only platform to enable users to purchase groceries from various suppliers, such as bakers and greengrocers. It then uses electric vehicles to deliver orders to customers' DoorDash at a low price. The efficient operation of an online supermarket service is very important, and it hinges on minimizing product waste and ensuring customer satisfaction. Consider the scenario that if the company accurately predicts demands for a specific product, if it underestimates the needs, then that would result in customers being unable to order the desired item, impacting the customer satisfaction. On the other side, if it overestimates demand, that would lead to excess inventory, especially for perishable items that would cause spoilage and contributing to food waste. Clearly, precise demand forecasting plays a crucial role in achieving the overarching objective. The team's goal is to predict what products will be ordered by their customers in the future, so that they can order the right amounts at the right time. And then they can automatically purchase those groceries from suppliers at scale. Now that we've understood the business problem to solve, let's dive into the data science part to see what the team's efforts are in pursuing accurate demand forecasting. We will examine this effort through three components of any machine learning product: the model, the data, and the system. First, let's take a look at the model choices. The team adopts a very practical approach to choose the right model. At the simplest format, the model can be just a simple SQL query. For example, there are some special products like bread, where the business requires the customer to submit their demand as a previous date. In this case, one SQL query can directly provide the most accurate customer demand estimation, and no further machine learning model is needed. In situations where demand forecasting cannot be achieved easily like the previous case, it is crucial to use a simple model first, before advancing further. There are two reasons behind this approach. The first one is that a simple model can usually provide a reasonable baseline, so that later performance improvements from complex model can be easily measured. The second reason is that the simple model is usually more stable, and it can provide a reliable fallback logic. By saying fallback logic, it refers in situations where the more complex model is unavailable, then people can still use the predictions from the simple model as a result to serve the business need. Understanding the principle of the model choices, the team shares two commonly used forecasting models as their simple approach. One of this model is ARIMA, A-R-I-M-A. It stands for Autoregressive Integrated Moving Average. The model uses linear regression to make predictions based on the time series data on past value. A Riemann model is a good choice for simple forecasting tasks, but it has limitations for complex patterns and can't handle sudden changes or unpredictable events. A second commonly used model approach is FB-Profit. FB-Profit is a forecasting algorithm and open source tool developed by Facebook's data science team in 2017. It forecasts the time series data using a decomposable additive model that breaks down time series data into trend, seasonality, and holiday effects. It is designed to be scalable, fast, and accurate, and also consider the impact of holidays, so it is a good choice to get started. Having tested these approaches, the team progressed to more advanced machine learning algorithms and explored deep learning algorithms, such as the temporal fusion transformer. A transformer is one deep learning component where it learns context and meaning by tracking relationships in sequential data. It deploys a mechanism known as self-attention to process sequential input data, identifying how distant data elements influence and depend on one another. This capability empowers the transformer approach to be very powerful, and the company leverages this approach as the state-of-the-art machine learning algorithms to be explored. After discussing about the model choice, let's shift our focus to the data perspective. The team firmly believes that garbage in, garbage out holds true for building machine learning models, where the effectiveness of the machine learning model is directly tied to the data quality used. And poor data quality inevitably lead to unreliable predictions. So that's the reason the team developed measurement approaches to bring clear visibility to the data status used for the model training. And they have built a comprehensive monitoring system to ensure that even when the team is not working on the model itself, the machine learning model is constantly under surveillance. In addition to data monitoring, they also utilize open source software to ensure data integrity and flag outliers in their machine learning pipelines. They integrated this validation into their training pipeline, inference pipeline, and any other associated data pipelines. So that ensures no surprise happens, either for those data going into the model or for those predictions going out of the model. After discussing the modeling choice and the data, we now dive into the third component crucial for building a machine learning product: constructing a scalable system. Given the business need, the company sells tens of thousands of products across various countries. It needs a machine learning software that not only robust, but also scalable and can operate with low latency. To achieve this, the team facilitates a closer collaboration between machine learning experts and seasoned software engineers. And then they design a machine learning architecture capable of handling greater volume of predictions. This approach leverages expertise from both sides, enable the team to build the system for pre-computing and delivering predictions to their purchase order management system. When saying pre-computing, it means that all predictions are calculated ahead of time in a batch fashion, rather than being generated on the fly. Although this design may seem less efficient, it ensures prediction robustness and proves to be even more efficient than calculating predictions when requested. This is because if a prediction is inaccurate, it can be identified ahead of time before surfacing for the business need. And if the advanced model encounters issues and cannot return result, the fallback logic can be leveraged to ensure some level of forecasting is provided. This is a much more desirable outcome from the business perspective. Now we discussed both the business problem and the data science solution. Let's wrap it up. In this episode, we discussed the journey of an online super grocery company, Picnic Technology, to develop a scalable demand forecasting solution. It covers their modeling choices principle, how to ensure data quality, and the way to build up their machine learning system. This makes it a good reference for those who may encounter a similar problem. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.